Okay. Bhaga, in the last, I think we start quantum numbers last week of this quantum theory of hydrogen atom. त्याच्यातला शेवटचा बीट आहे तो क्वांटम नंबर्स आणि क्वांटम नंबर मध्ये तुमच्या सिलेबसला 3 क्वांटम नंबर आहे. पहिला आहे प्रिन्सिपल क्वांटम नंबर किंवा टोटल क्वांटम नंबर, दूसरा ऑर्बिटल क्वांटम नंबर, and third is magnetic quantum number. And I think already we discussed all three. तिन्हीचंही डिस्कशन मी त्या दिवशी घेतलेलं आहे. What is the principal quantum number किंवा what is important, what is the need to study the principal quantum number, then why we study this orbital quantum number. Orbital quantum number, then magnetic quantum number. Why we study this principal or total quantum number? We know that this principal quantum number gives number 1, that is a principal quantum number, or it is also called total quantum number, and it is denoted by n. Remember this, it is to be denoted by n, and it gives the shape किंवा size of the orbit. शेप बद्दल म्हणण्यापेक्षा size of the orbit, शेप नंतर हे नाही. It gives the size of orbit. Also it gives the energy of electron in electronic orbit. Also it gives energy of electron in electronic orbit. म्हणजे बघा, it gives the size of orbit, or this gives you the radius of orbit. Size of the orbit or radius of the orbit. It means that मला वाटतं हे आपण पूर्ण डिस्कस केलेलं आहे की let I have to consider that this is the center of the nucleus, and in the nucleus proton is there, and around the nucleus in the orbit there is a electron is revolved in the orbit, and this is the radius. This is the radius of that orbit in which electron is to be revolved. Now, what we have to find? Simply we have to find here, by using this quantum number, by using this principal quantum number, we can get the idea about the radius of electronic orbit and energy of the electron in the electronic orbit. These things we get from this principal quantum number. It means that we know the equation of the hydrogen atom in spherical polar form. Schrodinger equation in hydrogen atom, for hydrogen atom in spherical polar form. And the equation we already separate the 3 parts. One part is a first part, that is a radial part, or which depend on radius, or we call it as a r dependent part, r dependent किंवा radial part. And we have to consider here the radial part of that Schrodinger equation, and that radial part is 1 upon r into dou by dou r into r square dr upon dr plus 2m r square upon h cross square plus 2m r square upon h cross square into is plus E square E plus E square upon 4 pi epsilon 0 r is equal to L into L plus 1. And this part already we seen while separating the Schrodinger wave equation in spherical polar form for hydrogen atom. When we separate it in three independent parts, out of them one is r dependent part, another one is theta dependent, and third one is phi dependent part. आता इथं मी काय घेतलंय for principal quantum number. What I said, principal quantum number gives you the energy and size of the orbit or radius of the orbit. And for finding the radius of the orbit, we have to use this equation. For finding the energy of the electron in the electronic orbit, we have to use this equation. Right? Okay. So by solving this equation, for solving this equation, we have to use Lagrange polynomial. We have to use Lagrange polynomial. आता ये math वाल्यांना माहित आहे. What is the Lagrange polynomial? What is the legendary polynomial? किंवा legendary function, Lagrange function. That things already known to the mathematics people. त्याच्यावरती आपण जास्त एक ट्रेस देणार नाही. फक्त लक्षात ठेवा, the solution of this equation can be given by using the Lagrange polynomial, and by solving this we can find the energy of the particle, and only the solutions are given or solutions are taken for the positive value of the energies. Positive value of energy. What is mean by the negative value of energy? Negative value म्हणजे काय हो? ह्या इलेक्ट्रॉनला जर निगेटिव्ह व्हॅल्यू म्हणलं किंवा E, मला वाटतं आपण याच्यामध्ये बघितलेलं आहे, E cannot have the zero value. No, E has a value. So n is equal to 1, 2 and so on, not equal to 0. If we have to consider E is equal to n is equal to 0, so E is equal to n square h square upon 8ml square. That equation, so this E becomes 0. This E becomes 0. What it means? If E is equal to, if we have to put n is equal to 0 जर मी ठेवला तर माझं हे इक्वेशन जे आहे, हे इक्वेशन काय होतं? It becomes 0. And it means that energy is 0. If energy is 0, it means that there is a non-existence of the particle. Particle does not exist. Energy 0 म्हणजे काय? Particle नाही आहे. आता energy negative, so it is meaningless. Energy negative means meaningless. So we can't consider the E is equal to minus values. But in special cases, some values of energy are to be considered as a negative, and that values are E is equal to minus me raised to 4 divided by 32. He direct कालेली value आहे by 32. By solving this equation, we can get the value. By solving this equation by using Lagrange polynomial, we get the value of energy. That values are in positive, but in some special cases, we have to consider the negative values also, and that negative value is me raised to 4 upon 32 pi epsilon 0 square r square epsilon 0 square, sorry, r square, h cross square into 1 by n square. And this is the value of energy, where n is the principal or total quantum. N is principal or total quantum. Okay, and by using this, आता इथं बघा, आता हा जो L आहे, L ला काय म्हणलं मी? N is principal quantum number. Similar to that, small l is orbital quantum number. So we can find that principal quantum number in terms of किंवा energy of electron in terms of energy of electron in terms of what? Orbital quantum number. So first we have to see what is the orbital quantum number. Principal quantum number लक्षात आला का बघा? काहीच नाही, त्याच्यामध्ये फक्त दोन गोष्टी आहेत, एक साइज ऑफ द ऑर्बिट आणि दुसरा एनर्जी ऑफ द ऑर्बिट किंवा एनर्जी ऑफ द पार्टिकल इन द ऑर्बिट, राइट? And this orbital quantum number L, this orbital quantum number L can be explained as, now see, for this orbital quantum number, आता पुन्हा बघा, if I have to say this R means radius of the orbit is to be given by principal quantum number n, from the principal quantum number n we get the idea about radius of orbit, and also we get the idea about the energy of the particle in that orbit. Okay, then orbital quantum number, मला वाटतं मी हे सुद्धा सांगितलं त्या दिवशी, the orbital quantum number L, this orbital quantum number L decide the shape of orbit. इथे काय म्हणायचं आहे? N decide size of the orbit, L, that is the orbital quantum number, orbital quantum number orbital quantum number decides, denoted by L, and it decide what shape of orbit, and the shape of the orbit is whether the shape is circular or elliptical. That was to be decided by using this orbital quantum number, and this orbital quantum number has the value 0, 1, 2, 3 and so on. 0, 1, 2, 3 and so on. आणि पुढे काय असेल? n ला n minus 1. Means म्हणून इथे मी L is equal to 0 घेतलाय. N is not equal to 0. N ची व्हॅल्यू काय असतील? The principal quantum number value has n is equal to 1, 2, 3 and so on. Not equal to 0. हे फक्त लक्षात ठेवा. But L can have the value 0. Means n minus 1 जर केला तुम्ही, means 1 जर घेतला n is equal to 1, so 1 minus 1 0. So L is equal to 0. Means the orbital quantum number which decide the shape of the orbit, yes, shape of the orbit gives the values L is equal to 0 also. And to solve, आणि पुन्हा पुढचा पार्ट बघा, this orbital quantum number L, this orbital quantum number L also gives the magnitude of angular momentum, magnitude of angular momentum L. आता ह्या L चं मॅग्निट्यूड म्हणजे काय, angular momentum म्हणजे काय ते आधी मला तुम्ही सांगितलं त्या दिवशी. Let's suppose to be my particle is at here in time t, and after time t dash it goes to here. So this made the theta, and this is the angular momentum. This momentum along the circular path is angular momentum, and this angular momentum, let I have defined it by L. So the magnitude of the angular momentum is to be given by this orbital quantum number. Magnitude of the angular momentum means what is the value of L, this capital L, and it can be found, that value is to be found by considering the theta dependent part. We have to consider the theta dependent part, and the theta dependent part is We know that the theta dependent part is 1 upon theta. Schrodinger equations are 1 upon theta into d by d theta, 1 upon theta into sin theta d by d theta into sin theta capital D theta upon d theta into is equal to L into L plus 1 minus ml square upon sin square theta. ml square upon sin square theta. By shifting this theta to that side, we get tile 1 upon sin theta into d by d theta into sin theta d theta upon d theta into किंवा याला जर मी डायरेक्ट इकडे घेतला तर काय होईल, it becomes minus of L into L plus 1 minus ml square upon sin square theta into capital theta is equal to 0. And this is the Schrodinger equation in theta dependent path. याला काही सुद्धा बदल केलेला नाही. Let's suppose to be this equation is equation 1. Okay, to find out the magnitude of the angular momentum, आता इथे काय मिळालं आपल्याला, व्हॅल्यू ऑफ काय म्हणतात थीटा. हा थीटा म्हणजे काय आहे, हा या थीटा तुमचा इथला हा थीटा. When we get the theta we can find this L. बघा, when we get the value of theta, so on putting the value of theta, फक्त theta ची व्हॅल्यू पुट करायचे, you will get the orbital quantum number L, and from this orbital quantum number L we can find the magnitude of the angular momentum L. And to find the magnitude of angular momentum, we have to consider again the Schrodinger equation in radial part, and that radial part equation is 1 upon r square d upon dr, 1 upon r square, that is d upon dr into r square dr upon capital R upon small r into किंवा डायरेक्ट मी आता ते इक्वेशन इकडे घेऊनच घेतोय 2m upon h cross square 2m upon h cross square in the bracket e square upon 4 pi epsilon 0 r plus e minus L into L plus 1 upon L into L plus 1 upon r square into capital R. Is equal to 0, and this is the radial equation in the Schrodinger wave equation in radial part. Now by solving this complicated equation, we can solve this complicated equation by using legendary polynomial. आता इथे कुठला वापरला आपण, Lamoury polynomial. Now I have to use here legendary polynomial. By solving this equation by using legendary polynomial and we can get the we can get, मग आता इथून काय ह्याची व्हॅल्यू काढणार आपण by using this we get the magnitude of angular momentum L, and to find the value of angular momentum we get, first we have to know the energy of that electron in the electronic orbit. So in the electronic orbit the energy of the electron is nothing but the combination of two components, and that two components are, one is energy in orbital energy किंवा इथून इथपर्यंत घेणार आहे म्हणजे कुठली बघा it is moving. Let I have say that the angular momentum is there. Momentum is there means it has the kinetic energy only. So the kinetic energy, it's kinetic energy. So the total energy of that electron in the orbit is equal to kinetic energy plus potential energy. किंवा I have tried पुन्हा potential energy. तुम्ही काय घेतलं E plus potential energy. This E square upon 4 pi epsilon 0 R is the potential energy, and that already we मागे आपण घेतलेले V is equal to minus E square upon 4 pi R 4 pi epsilon 0 R. हे already we consider हे ऑलरेडी घेतलेलं आहे ठीक आहे. मग त्यामुळे पुन्हा मला वाटत नाही ते सांगायची गरज आहे. मग आता बघायचं this kinetic energy of the electron in the electronic orbit. This kinetic energy of the electron in the electronic orbit is also divided into two components, and that two components are, this kinetic energy is equal to T radial means radial kinetic energy and plus T orbital. Second one is orbital kinetic energy, and these two kinetic energies are to be taken, and the total energy is equal to kinetic energy plus potential energy. So this total energy E can be written as T radial plus T orbital plus V. आता इक्वेशन मला वाटत नाही आपण दिलेले आहेत म्हणून वर कुठे ठीक आहे नसतील दिले याला मी स्टार्ट करतो काय करणार ऍक्च्युअली इक्वेशन नंबर द्यायला पाहिजे हे बघा मी याला या इक्वेशनला 1 दिलाय ठीक आहे हा रेडियल पार्ट आहे याला 2 देतोय ठीक आहे याला 3 देतोय सोपं पडतं ठीक आहे. Then now put the value of E is equal to, now put the value of E is equal to, what is the E किंवा this first put the value of V, and we know the value of E is equal to T radial plus T orbital plus V is, we know the value of V is equal to minus E square upon 4 pi epsilon 0 R. So on putting this here we get minus not plus minus E square upon 4 pi epsilon 0 R, and on shifting this to this side is E plus E square upon 4 pi epsilon 0 R is equal to T radial plus T orbital. So give this as equation number 4 by using equation 2 by using equation 4 by using equation 2 becomes, and it becomes 1 upon r square d upon dr in the bracket r square dr upon dr in plus 2m upon h cross square into E square upon 4 pi epsilon 0 R plus E. याच्यासाठी काय लिहिणार आहे मी I have to write this T orbital plus T radial किंवा टी रेडियल प्लस टी ऑर्बिटल केला कुठलाही तरी चालते. पुढचा आणि हे मायनस ॲज इट इज मायनस L into L plus 1 upon R square. काहीच करत नाही, फक्त आपण त्याला हे करतोय. काय घेतलं, फक्त व्हॅल्यू पुटअप करतोय आणि पुढे 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 चालू. ठीक आहे. नाव द नेक्स्ट थिंग बघा, if I have to take common this 2m upon h cross square. अच्छा, इथं हा ब्रॅकेट किंवा काय हरकत नाही, जरी इथं क्लोज केला असला तरी चालतं. देन 1 upon r square d upon dr r square dr upon dr. रिमेनिंग इक्वेशन सेम लिहायचं आहे बाकीचं, प्लस मी काय करतोय आता, 2m अपॉन h क्रॉस स्क्वेअर बाहेर घेतोय आणि इथं काय असेल, t ऑर्बिटल प्लस t रेडियल. ठीक आहे, मायनस याच्यातून h क्रॉस स्क्वेअर अपॉन 2m r square as it is r plus cos into L plus 1. ठीक है, and this equation is equation 5. So from this equation we can write that from this आणि अच्छा एक राहिला इक्वल टू 0 आणि मग 5 लिहा, याला सुद्धा इक्वल टू 0 लिहायला. Then from equation 5 किंवा ओके, from equation 5 we can equate what we have to equate. See, t orbital minus तीच टर्म घ्या, कुठली आहे ही टर्म बाकीची, h क्रॉस अपॉन 2m r स्क्वेअर, h क्रॉस स्क्वेअर अपॉन 2m r स्क्वेअर into L plus 1 is equal to 0. And t radial part is also equal to 0. आता मी काय केलं, पहिल्यांदा ऑर्बिटल पार्ट घेतो. सो ऑर्बिटल पार्ट इज इक्वल टू t orbital is equal to h cross square upon 2m r square into L plus 1 and we know that the kinetic energy of the particle, orbital kinetic energy of the particle is to be written as, that is t orbital is equal to half mv square, half mv orbital म्हणजे orbital velocity square. So we know that this half mv square, or we know that again this can be written as p square upon 2m. बरोबर आहे का? That is p is equal to mv and v is equal to L upon mr. V is equal to L upon mr. So on putting this V is equal to L upon mr, in this equation we get t orbital. आता हे काही नवीन नाही आपल्यासाठी. p square upon 2m किंवा p is equal to mv. जर p is equal to mv घेतलं तर काय होईल? m square v square, that is p square, आणि upon 2m, p square upon 2m. This can be also written as a p square upon 2m किंवा p is equal to mv, right? Then t orbital is equal to half n into half m into m into L v square L square upon m square r square. बरोबर है? And it becomes t orbital is equal to half L square upon m r square. Right? Give this as the equation. Okay. This is equal to t orbital. And this equation is equation number 6, and now I have to put here 7. So by using 7, equation 6 can be written as, on comparing 6 and 7, on comparing 6 and 7, we get, what we get? But p orbital is equal to, so I have to write directly L square upon 2mr square is equal to L square upon 2mr square is equal to h cross square upon 2mr square into L plus 1. On rearranging it, this 2mr square gets cancelled. So the remaining is L is equal to h cross square upon h cross square into L plus 1. Sorry, L square, here L square is equal to, so L is equal to h cross under root of L into L plus 1, and this gives you the magnitude of this equation 8. Equation 8 gives the magnitude of angular momentum. Magnitude of angular momentum, and the magnitude of angular momentum is in the order of h cross, that is Planck's constant. It is in the order of Planck's constant. Okay, this is the magnitude. Now I want to find its direction also. बघा बरोबर आहे का? Angular momentum चं magnitude मिळाले मला, and the magnitude is this much. L is equal to h cross under root L into L plus 1. Right? And the value of small l are 0, 1, 2, 3, and so on. So to find out, to get the angular momentum, the magnitude of the angular momentum by using this, so the value of that angular momentum, the first, what is that? orbital quantum number. This orbital quantum number gives 0, 1, 2, 3, 4, 5 and so on. So 0 indicates that s orbit. L is equal to 0 means we are in the s orbit. Okay? Then 1, L is equal to 1 means we are in the p orbit. What means electron in the p orbit, electron in the s orbit. Okay? Then पुढचा कुठला आहे S P D F S P D F G H आणि जर आणखी पुढे असेल तर मला वाटतं पुढे I आहे 6 I and so on. मग आता L is equal to काय असेल त्यानुसार तुमचा अँग्युलर मोमेंटम असेल. L is equal to 0 असेल, angular momentum have the value, the electrons are in the s orbit, electrons are in the s orbit and the magnitude of the angular momentum is related to the s orbit. बरोबर आहे. If L is equal to 1 then electrons are in the p orbit and the magnitude of the angular momentum is related to the p orbit. And this is about the orbital quantum number. And then next is magnetic quantum number. Then हा इथे काही अडचण आहे का मला सांगा बघा, लक्षात येत आहे का? काय अडचण वाटत असेल विचारू शकताय. याच्यामध्ये जर समजा तुमचा एमसीक्यूचा पेपर झाला तर या ऑर्बिटल वरती क्वेश्चन येऊ शकतो, टोटल एनर्जी किंवा ऑर्बिटल क्वांटम आणि ऑर्बिटल क्वांटम नंबर मध्येच तुम्हाला ऑर्बिटल कायनेटिक एनर्जीचा क्वेश्चन येऊ शकतो, रेडियल कायनेटिक एनर्जीचा क्वेश्चन येऊ शकतो, सोबतच स्मॉल एल आणि कॅपिटल एल यांच्या व्हॅल्यूज वरती येऊ शकतो. स्मॉल एल म्हणजे काय ऑर्बिटल क्वांटम नंबर अँड इट्स व्हॅल्यूज आर एल इज इक्वल टू 0 1 2 3 n-1 हे फक्त लक्षात ठेवा. याच्यावरती क्वेश्चन येऊ शकतो, प्लस तुमच्या कॅपिटल एल वरती क्वेश्चन येऊ शकतो. ठीक आहे, जर एमसीक्यू असतील तर माझ्या माहितीप्रमाणे याही वेळेस तुमची एमसीक्यू होण्याचा चान्स आहे. याही वेळेस
एमसीक्यू नाही एक्झाम एमसीक्यू
एमसीक्यूच होण्याचा चान्स आहे. मग आले सर्क्युलर आलंय, फर्स्ट इयर सेकंड इयर थर्ड इयर एमसीक्यू होतील सांगितले त्यांनी, पण सांगू शकत नाही. थर्ड इयर साठी एखाद्या वेळेस बदलायचं असेल तर बदलू शकतात, त्यामुळे तयारीत राहा.
सर ते 2017ची एक्झाम एकदाच म्हणाले तर ती काय कन्फ्युज झाले सर. तर
2017च्या एक्झाम नाही रे तुमच्या एक्झाम आता होतील. 2017च्या म्हणजे कुठल्या, तुमच्या एक्झामची डेट आलेली आहे. 2017च्या म्हणजे बॅकलॉग जे आहेत त्यांच्या, रेग्युलर वाल्यांचे 2017 एकदाच होणार नाही, बॅकलॉग
भरपूर वेळ आहे. मग
आता समजा फर्स्ट सेमिस्टर, आत्ताचं फर्स्ट सेमिस्टर आहे, या फर्स्ट सेमिस्टर सोबत काय असतंय, मागच्या वर्षीचे जे बॅकलॉग आहेत